Hey everybody. So this is at this point we're looking like we're going to be solid all YouTube today, and that's just great. Well, it's not super great. I love the comments, love the interaction, but it's okay in the sense that we are going to pound through. Morgan's here. Okay, me and Morgan, we're doing private, whatever, just small group, small group get together. Anyway, Morgan, burden on you, man, to carry the load on interactivity. But and I guess Zach's going to join, so that's awesome. So anyway, but I'm just going to go. I'm just going to take off, and we got to get through this stuff anyway. And we're definitely running a week or two behind. Looking at the grand schedule, we are. Yeah, we're about a week and a half behind, which isn't crazy, but it's still not ideal. And then we will catch up. The later modules go pretty quick. They start popping pretty fast. They're also smaller and easier. So, okay, let's do the thing. Right. Hey, Mike. So yeah, we're going small group. Most everyone's going to be on YouTube. Okay, so here's where we got to. And it is Wednesday, the 4th of November. And I'm not going to talk about politics. I'm not going to talk about any of that stuff. I'm going to talk about some cool LC3 programming. That's what I'm going to talk about. And this is, I think, what we got to was we walked through the this sort of flow chart, right, to kind of see how we're going to do this thing and how we would do this loop, right, to sum all the numbers in 12 consecutive memory locations in these spots. And we kind of did this in sort of pseudocode flowchart. And what we're going to do right now, because you're excited about it, is we're going to walk through what this looks like when it's actually in the LC3. And what I would recommend you do, and we can kind of maybe get to this or even do a help section about it, is take this binary, take just these binary numbers, and just drop that into the LC3, okay? Just take these numbers. Now, if I had my act together, I would have already had those. We could just take this program and just put it in the LC3 as binary and then just kind of walk through it. But what you don't get from that is the LC3 still gives you a view of everything kind of from the assembly language view. You can drop it in as binary, but then you're going to get a view that isn't going to show you this exact view, okay? And hey, I wanted to just do a quick double check, Mike and Morgan. Audio okay? Are we okay on, you're hearing me okay?
Yeah, it's coming through.
All right, awesome. Thank you. Okay. So here we go. We're going to start right here. We're going to say that the program counter is 3000. Sometimes would say things like 3000 hex. It's a little confusing because 1000 is that's a base 10 number, right? Yeah. All right. Hey, Cody. It is a big group. It's a big live group. I think I probably jacked it by pushing it off. I just had a conflict that jumped on the schedule today, induced by a follow-up thing for this. I'm going to blame all of our course struggles on my son now and his pitiful retina, which is doing great, by the way, but we had that jump in. Yeah, I could blame the election. Yeah, I was up real late. I didn't get up until about 2 minutes ago. No, that's not true. Well, it is true that I was up too late. It's not true that I just got up 2 minutes ago. All right, so here we go. And once again, where's my, sorry, let me grab my, the cheat sheet. Let me grab that real quick. And if you have yours, not a bad thing to just kind of have that handy. Okay. I was accused today in public of being Santa Claus. I just like to share that with everybody while I'm pulling this up. It is a little tough to mount a plausible defense, against that idea. I just, you know what I mean? I think I'm rocking the Santa look over time. Don't you think? I think, yeah. Okay, so here we go. Let me get rid of that, make that just a little smaller. Okay, so we're going to start. I'm just going to walk through this thing, and it's going to be fun and exciting, and we'll get through it. Okay, 1110, what's the opcode? So we just go look in here, and that's load effective address, 1110 right there. Okay, and what we're going to do is the destination register is register 1, and that's the value. Okay, that is a PC offset. If we go back to right here, the LEA, right, it's a PC offset 9. And it turns out, you're just going to have to trust me on this, that this number right here, which is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 is, well, there's actually a couple ways of looking at this. The PC has already been incremented, so the PC is currently 3001. And what is this whole number plus 1? If you look at them, do the math, right? It's basically, it's 100, right? You got these 4 become 0, then these 4 become 0, and there's a 1 that spills over. And so you're adding that positive number to 3001, and you get 3100. Okay? So that is, essentially, you're adding FF, okay, to 3001. And you're adding FF, which is this value right here. Everyone buying? 4 bits for an F, 4 more bits for an F. It's a positive number. Okay, so we take that value, 3100, we put it into R1. Let's go 0101. That's an AND, right on. 0101, that's an AND. We're going to take the contents of register 3. Immediate value, we're going to AND it with a 0. So, which means that'll just become 0. And we're going to put that result back into register 3. Boom. So we cleared register 3. And then you should be able to see we're going to do the same thing with register 2. Take the contents of register 2, AND it with 0, put it back into register 2. And by the way, it really wouldn't matter what your source register was here, right? Doesn't matter what you pull out from anywhere. It's conceptually cleaner to just go register 2. That's what we do here. So our 3 becomes 0, our 2 becomes 0. We clear it. And now we're going to go 0001, which you probably remember is an add instruction. And we're going to take register 2, that's our source, immediate value, and this number right here. It's positive. That's a 5-bit number. It's positive. It's a no 1s, no 2s, so it's a 4 and an 8, that's 12. So we're going to take the contents of register 2, add the value 12, and put that result back into register 2, which causes 12 to be placed into register 2. Okay? And that's just the setup. If we go back, that's just this part right here. Okay? Get 3100, right? Because those are the spots we're looking at. Get that into register 1, clear register 3, and get a 12 into register 2. That's all we did there. What we're going to do now is ask a question. Are we done? And R2 is our counter. It's going to go from 12 down to 0. When it gets to 0, we're done. So what we do is we branch on 0. Now, that's the way we encode that. That's what we say that in assembly. BR with a little z. The way we do it here, you might remember that branch was the branch instruction. Where is it? Was all zeros. The opcode was 0000. So there's all zeros. We're going to branch. Oh, these 3 bits, NZP. These are the NZP bits. We're basically saying, don't care about the N bit. Do want you to look at the Z bit. Don't care about the P bit. Well, so what that says is, if Z is on, take the branch. If Z is not on, just drop on through. Don't do anything. Don't go crazy. Just drop on through. And this is a PC offset 9. Yeah, that's PC offset 9. All right. And if you look at this value, the incremented program counter is 3005 at this point, right? And this value is 5, right? 1, no 2s, and a 4. So 5, positive 5. So we take 3005 and we add 5 to it. That is 300A, right? So what you're going is 1, 2, 3, 4, 5. So it's basically jump around it to whatever comes after. So when R2 gets to 0, then we jump around. But if not, we drop in. Okay? That's the concept. And then notice at the bottom of this loop, another branch. Only see what we're doing here? They're all on. Because it's like, hey, if either the N bit is on or the Z bit is on or the P bit is on, you should probably take this jump. Right? So that's an absolute jump. And where are we going? Negative number, negative number. What is this negative number? Let's see. Let's look at it. Flip all the bits and you get 101. Add 1 to that and you get 110, which is 6. So it's negative 6. And you're already incremented, so you're right down here and you go 1, 2, 3, 4, 5, 6, right? Which is right to the top again. So you jump right back to the top where you make the check, okay? Because what you're doing here in the middle is you're pulling a value out of memory, you're adding that value into the running total, you are incrementing R1 to look at the next spot in memory, and you're decrementing R2, so you're counting down from 12. You do all those things, then you hard jump to the top right here to location 3004, and then you branch on 0 at that point. Okay. Now there's one really important thing here, and I know I'm moving really fast, so I apologize a little bit. This is really important. That control bits that it's looking at, right? We said look at the Z bit. Well, the last thing we did has to be the thing that affects the Z bit in the way that we would want, which means the very last thing we have to do is decrement R2. If you did R4 last, then the control bit would be set on based on that. If you did the summation last, see what I mean? It would be set on that. If you incremented R1, it would be whatever you wrote to a register last is what is going to be there when you check the control bit. And by the way, here when I do the BRNZP, which is an unconditional jump, that doesn't affect the control bits at all because I didn't write anything to a register. Up here, same thing. So you've got to decrement R2 last of all. Take this thing down. So then what I do is I go, if I'm going to drop through, like let's say we first started, right, and this guy was 12, R2 was 12. Branch on 0? No. R2 is not 0. So we fall through. We take okay, let me back up. We got instruction 0110, 0110, which is that guy. The highlighting's off on the PDF, but 0110, okay? That's LDR. That's base plus offset. And so the base register has an address. The offset gets added to that address. At that location, we grab the contents and we put it into the destination register. How do we know this is what's going to happen? Social contract. Okay. So, The offset is 0, so we're not worried about that. We're saying register 1. What's register 1 got in it? 3100. We told it what address to pull from. So we go out to location 3100, grab what's out there, put that into register 1, right there. Sorry, we put that into register 4, right? That's 4 right there, and there's R4. So now R4 has the value, the next value we're adding into the running total. R3 is keeping the running total. That's an add. We know that one by now. From R3, bit 5 is a 0, which means the second operand is also a register. These two zeros are just, they're reserved. We don't touch them. We make them a 0. So we take the contents of R3, we add that to the contents of R4, take that summation, and put that into R3, which is what this pseudocode says. Now we got to increment R1, so we're pointing to the next spot in memory. There it is, add. We take R1, immediate value, we add 1, and we put the results back into R1. So that just increments R1. We got to decrement R2, so it's counting down from 12. So there's add, there's R2 source, immediate value, 5 ones. If that's a 5-bit 2's complement number, that is -1, my friends. So this is contents of R2 minus 1. It just adds those together and puts the result back into R2, and then we do an absolute jump. Now at this point, R2 is 11 that first time through. So R1's now pointing at the next spot. R4, we don't care, we used it. R3 has the running total. R1 points to the next spot, and R2 has been decremented. Boom, go up here, and we just check. Because we just decremented R2. R2 is now 11, so it's like, branch on 0. Nope, nope. The last value written to a register was not 0. And we drop in again, and we just do that 12 times. Until finally, R2 will be 1. We'll grab the value, put it into R4, add R4 to R3, put that into R3. We'll increment R1 to point to the next location. We'll decrement R2, and R2 will become 0. We'll absolute jump up here, and then right here we're going to look at the Z-bit. And now for the first time since we started that process, the Z-bit's going to be 0, which means it's time to kick out. And we will, in fact, kick out, boom, and we'll drop out. That, my friends, is a for loop in machine language. Slow clap. Slow clap for for loops in machine language. Anybody have anything clever to say about that? It's a lot of work, isn't it? No, they can actually. They can clap, Mike. I'm quite confident of it. But this is the deal, right? I mean, it's tedious, it's tiny, it's microscopic, but this is what you have to do to make the computer do a for loop. All right, this is what underlies it. Okay, I'm going to move on. I'm just going to keep going because we've got so much to cover. All right, now what we did was we call that process iteration. Okay, it's iteration. We iterate, and iteration means you go through a thing, over and over and over again. As many times you go through it as many times as you need to. A for loop, right? A for loop that has you do something 10 times is iterate. It's a form of iteration where you're going to iterate 10 times. Each time through is referred to as an iteration. So it's a little bit ambiguous that the process is called iteration and one time through is called an iteration. How many iterations? I don't know why. That is a term, and it's a term that we use in the field. So you need to know that. You need to know that term. So there's two different ways of doing this, broadly speaking. There are more than that, but really broadly, there's two big ways of controlling iteration. What we just did was a counter. We said make a register 12 and start counting it down to 0. When it gets to 0, we'll stop. You could also do other kinds of checks, right? Using the control codes. You could count up to a certain value, like I'm going to count up to 50, and then to check it, I could do, there's no check to say when it gets to be 50, then stop. But I could do something like take that value, add it to negative 50, and when that result is 0, then I'm done. I could do other tricks. But mostly, it's easiest in assembly language to count down. The other thing we can do, the counter requires that we know how many iterations that we're gonna do. If we do a Sentinel, it doesn't require that we know all that. Okay. So here's an example. We're going to give you one example of doing this same idea with a Sentinel. Now, what this means, what the Sentinel means, is that I'm gonna look at the data like I'm doing, right? I'm gonna pull each of the values out of memory, and I'm gonna go until the value has a certain well-known value, like for example, -1, or even that it's a negative number. If I say I'm adding all these numbers and I assume them all to be positive, right? Then I'm kind of free to put -1 as my Sentinel, as my marker that says, just keep adding them up until you find the -1. When you pull a number and that number is -1, then you're done. Okay? So in that case, what we would do, we would set it up very similarly. R1 points to the spot in memory where the first number is, and R3, which is the summation, gets set to 0. But then the last thing we do before the check is we pull the value out of that location in memory and we put it into R4. What we did on the previous example, if you would remember, is we were using R2 as the counter. So the last thing we did before the branch check was initialized the counter to be 12. And immediately is like, are we at 0 yet? No, drop in. What we do now is, because we're looking for a Sentinel, we ask the question, we grab R4 out of memory. And what we really are saying is, look at R4. Is it negative? Is that a negative number? Is it -1? Or is it a negative number? If it's a negative number, we're done. If it's a non-negative number, we keep going. Okay? And that's the idea. I don't know how many times we're going to do this, but we're going to do it until that condition holds. Then at the end of every, inside every loop, we add R4 to the running total. We increment R1 because that just moves us to the next. Every time through the loop, we look at the next location. Now we're moving down the thing. And then before we make our loop, we pull R4 again. So when we get to the top, we can check to see if the next R4 is the Sentinel. Okay? Cool? And it turns out when you do strings in C, what literally happens, remember that you've got all these, the ASCII values, right? If I have a string in C, we actually put a 0 at the end of a string, and we call it null terminated. Okay? We also sometimes refer to it. Hang on, let me get my whiteboard. We sometimes refer to it as, did I put it there? No. We sometimes refer to it as ASCII Z. Okay? It's just a term you might see. ASCII Z, which basically means a null terminated string, which means you assume that every social contract, okay? You assume that every one of the elements of this array is a character in ASCII. So there's an ASCII character, ASCII character, ASCII character. And then finally you get 0. And when you see the 0, you're done. The string that's the end of the string. What if you overwrite the 0 or blow the 0 and you're like trying to print that string? What'll happen? Answer, you'll just keep going. You'll just keep printing the world whatever comes after, you'll just keep dumping all of memory to the screen until you find a 0 in memory, and then it'll think that that's the end of your string. Okay? Or if you're like uppercasing a string and you don't have the string null terminated properly, or you've overwritten it or trashed it somehow, it'll just add, the number is, you subtract a certain number, right, to create an uppercase ASCII value, right? It'll just keep rolling through memory, subtracting a value out of whatever is in memory until it gets to a 0. It's going to wreak a lot of havoc. Oh, one other thing I wanted to say in case the question's in anybody's head. This part right here about R3, gets R3 plus R4. In our dumb little program, there is no checking for overflow. We're just adding integers. And in our world right now, we're just assuming that whatever we add is going to fit, and we're just not dealing with any overflow issues of, how big that number is getting. Okay? Everybody cool with that? Just for simplicity. Okay. Now, it turns out I'm going to do this really, really fast. Hang on a second. I lost my marker. Second. I'm going to do this really, really fast because you're getting good at this and it's not so shocking anymore. Here we go. This is our program to use a Sentinel. We load effective address. We put 3100 into R1. That's the spot in memory that we're starting to add this array of integers. We clear R3. We pull the value that R1 points at out of memory and put it into R4. And then we branch on negative. So if that value we pulled is negative, we kick out. How would we tell? Because we wrote that value into the register, and the last thing that happened to a register in terms of writing a value to a register before this check was the value gets put into R4 ahead of it, and at the bottom of the loop, the value gets put into R4. Okay, just before this check. So here we jump absolutely up to here, and we're still checking about R4. Okay, so this guy right here, whether you're initializing or in the loop, the last thing before this instruction is R4 getting a value out of memory. Okay, that's it. This is the part where we add the two values. We add it into the sum. This is the part where we increment R1 to point to the next location in memory. And then this is the part where we grab the value at that location in memory. So this is the same function, only I don't need to know that it's 12. I also don't, it's also easier. I mean, I've got, notice that I've got, 8 instructions here. And what did I have here? 4, 8, 10. So much worse. 8 versus 10 instructions. I don't know. 25% more expensive in terms of memory. But it is simpler in that respect. There are reasons why you want to be able to just have that number into account, and there are other reasons why you would want to do a Sentinel. Okay? That's it. All right. Then I'm just going to keep going. It pains me to just roll here and not knowing if everybody's along. But we also got, the office hours, TAs, me, other times. Okay. Jump instruction. Let's go back to the, right over here. There's jump. And basically, that's, okay, so 1100, so that's the instruction. That's the opcode, I mean. These 3 are reserved as zeros. Those 6 are reserved as zeros. We don't touch those. And then there's just a base register. So whatever address is in the register that we indicate, we're jumping there. That's what we're doing. And the way we jump there is we just take that value and we just put it in the program counter. That's it. That's it. Here's the thing. Why is this a thing? Well, all the conditional branches, if you remember, in fact, if we go back over here to the branch instruction right there, right, which is the conditional branch, I can make that an unconditional branch by by putting all these as ones. But I'm limited to 9 bits, so plus or minus, around 256, right? It's plus 255 and negative 256. But there's 512 different possible things and about, 256 to either side. So that's fine and dandy if you're jumping around close by. It's not fine and dandy if you're trying to jump all the way across the other side of the country. Some other part of memory. That's it. So you got to get the value into the PC, okay? And then we're going to just we're going to jump to whatever the value is in the base register. Whatever that register is, in there is a value. We're going to take that value and say, that's an address. Load that into the program counter. That's it. This one I'm only going to barely touch on, which is the trap instruction, which is another form of subroutine call, subroutine jump, where we're going to get into it in chapter 9. Okay. But the bottom line is we have these kind of predefined routines built into memory, okay, in the LC3. And we can even make our own. But when you make this trap call, in fact, if you look down here, trap. So that's the opcode is all ones. That's hard coded right there. I can't do it. Come on, man. What's going on? Sorry, I'm getting ready for 4 years of Biden, or 3, or whatever it takes him to keel over. And so I got to work on my, come on, man. I don't know. I got to work. It's got to become slower and more, you know what I mean? It's got to become more slower and more desperate. But I'm trying to work on it. But it is what is called a trap vect 8, meaning it's 8 bits, and we call it a trap vector. And all that really says is, what's the number of the trap call? And we'll talk later about kind of how that works. It's fairly cool. That's all I want to say about trap stuff for now. Okay. But okay, I lied. I'm a lying sack of crap. These are the built-in trap vectors in the LC3 that it kind of comes with, okay? Trap 20, these are hex values. 20, which is a get character. This is outputting it, putting a string out, outputting a string. Inputting, putting, what is SP? I can't remember. And then there's a halt, which we'll talk about all of these. And I want to remind you, once again, that these will be provided for you when this is just a scan out of the book. Okay, right here. There's the trap vectors. There's the instructions. Put SP. Write a string of ASCII characters to the console. It's 2 characters per memory location. Yeah. And then put S has 1 character per memory location. So this gives you the instructions about, how these things work, so that you don't have to memorize that. It'll be given to you. But you've got to understand it, or it's not going to help you. You can't roll in there and never have seen it and then be like, oh, I'm going to figure it out on the fly. Okay, now, so here's one example. I'm going to do one real quick example, and then we are going to bounce. So Zach, if you're on here, I don't know if you're on yet. Nope. But we are going to make I think we already made the deadline for Module 6 a week from yesterday, which is all fine and dandy. But we're going to look at counting occurrences of a character, which also sounds really like some cool alliteration. The idea is you input a character from the keyboard, and then you're just going to look at a file, and you're just going to count how many times that character occurs in the file. And then we're just going to display that count. We're going to limit the number to 9 just arbitrarily. And this is it. Okay, look. This is the last slide from this lecture. I just want to show you just the logic of how you would do it. Okay? We need some counter right? And we initialize it to 0. We're going to use R2 because no real reason. We're going to initialize a pointer to be the starting location of some spot in memory. We're going to get a character from the keyboard, and that's a trap instruction to get that value from the keyboard. We're going to then pull a character out of the file, which is, without getting all the way into it, right, R3 points to the beginning of the file in memory. So we're just going to grab the value out of there, and we're just looking to see if that value that we pull out of there is the end of EOT, end of T, end of file marker, end of, what does the T stand for? Doesn't make sense to me. But we're using a Sentinel. When we hit the end of file, if that's true, we drop out. If it's not true, we're not to the end, then we're checking, is the value we pulled out of the file equal to the Sentinel that we set up, right? Which we have to have set that Sentinel up. Not, I mean, that, you know what I mean? The, sorry. The character, where was it? Oh, right here. This input character from the keyboard, it puts the value into R0. So that's why we're comparing to R0. If they're the same, then we increment the counter. If it's not, we don't. Then we get the next character from the file, we increment the little pointer, and then we pull the next value and we jump back to the top. Are we done? And you go vroom, 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 vroom. When we finally hit the end of file, we drop out and we prepare the output. Okay? That's it. And this is where we turn that value into an ASCII thing. Then the trap 21 just spits it out. And this trap 25 is the halt instruction, where you have to tell the LC3 computer to stop doing the fetch, decode, execute. You know, program's done. Okay. And again, go back through this, try to understand. This will make more sense later on as we get more and more into this, okay? And again, the issue is one of fluency. Fluency is critical, and fluency is acquired by regular exposure to the stuff, okay? And the only way to get that is to budget some time, okay? Okay. Let me see. I'm just pulling up the the chapter 6. Okay, this one's not going to be too bad. You're like, yeah, shut up. You know it will be. No. What I'm going to try to do here, you have everything you need to program in machine language, okay? And what we're going to do in this lecture is show you a little bit about designing and doing programming, okay? Now, I just realized something, because I have a little bit of an audio thing, and I'm trying to figure out what's the best way. Okay, well, we'll figure this out. We'll figure it out. Okay, so here we go. Lecture, whatever this thing is. It's chapter 6, okay? We're cooking with gas. Chapter 6. This one, we will finish. We won't finish. We probably won't finish it today, but we'll finish it on Tuesday. Okay? And this is really, okay, here's the thing. With chapter 6, mostly this is about design and debugging. This is about strategery, okay? This is about figuring out how to do good strategies for doing design and for doing debugging. The skills you're actually programming are basically just the ones that we've already learned in the chapter 5 lecture, okay? Those instructions, dropping into the LC3 Simulator, which we did a little bit, showed you a little bit. In fact, I want to do something. I'm going back up because Zach, who is not here to defend himself, he posted, there we go, there's Zach's code. He posted some code on the chat stream, right? Remember that? If some of you saw that on the chat thread, whatever. So I have grabbed it, and I'm just going to pull up the LC3 simulator in webular form. Okay, so there's LC3. I'm going to try to blow it up a little bit for your visibility factor. Okay, I want to just encourage you again, start now. Now. It could even be literally right now. Start right now with using the LC3 simulator. This is your tool. This is your tool for the rest of the semester. Notice, we talked about this. There's the program counter. In this simulator, it just defaults to 3,000. It doesn't matter. That's just kind of the thing. Instruction register has nothing in it. The control codes are, the last thing done, and all the registers are empty. Now, here's what you do. Down here, assemble and raw. Okay, raw brings up this guy right here, and it's like you can write raw, hex, or binary. All I did was just grabbed the bits. Oops. That Zach had dumped to the thread. Okay, that's it. And we can walk through these 0011, 1110, right? And then a bunch of this stuff. 1111 is a trap instruction. But so what we're going to do is we process, and it's like, yeah, that was great. You want to load that into the simulator? Yes. And in fact, let me see, does that, because I did this and ran it. Oh, and it turns out when you're doing the raw thing in the LC3 in this simulator, the very first 16 bits you put there is going to be the address that it will load your program into memory, okay? Thank you, Mike. It is less intimidating than it looks. Thank you. So this 3000, that's where it's going to put it. And then it just, all the assembler's doing here is like going, okay, 1110, what is it? It's load effective address. It's just doing the parsing for you, okay? So here it is. So, and then all this is just the hex of those instructions. And in fact, I'm going to drop it right here just because, wait, what did Zach do? He did like some cool format on that. Let me see. Nope. Just a second. I'm not sure. I'll just dump it. I mean, it's just not going to be pretty, okay? But that's the stuff right there, okay, that I just put on the chat thread. So that first one, right? E002. Go look at it, right? What have I got? 1110, 00, and there's 2, right? It's all the stuff we've been doing. And then this stuff, it goes load effective address 3003, which is right here. So let's go through it. So what we're going to do is we're going to do, you can step, which I'm going to do. So step executes the next instruction, and if it's a subroutine, it drops into it. Okay? Next, if it's a subroutine, it skips over it. It treats it like a unit. Okay? So I'm going to do next because I don't want to drop into the put S or the halt. Okay? So I go next, right? So what that's supposed to do, LEA, is supposed to take this value 3003 and put it into R0. That's what it did. See right there? Boom. It did that with a PC offset 2, right? The PC offset was 2. And this was the incremented program counter, 1, 2, 3003. And there's the incremented program counter. Okay? Now it's going to do a put S. It turns out put S prints a string. If you look right here at 03, does this look at all familiar? What do you notice about these numbers? 48, 61, 70. These are, you know, these are ASCII values. Well, they look like ASCII values. We can treat them like ASCII values. And if we point a value and then do the, you have to put it in R0, and you do a put S. Okay, check it out. There you go. Happy Halloween. And then the next thing you do is you run the halt instruction. Okay. So let me unhalt. I'm going to clear it all. I'm going to reset all the registers. Okay, here we are back at the top again. I'm going to clear the output, clear the input buffer, and we're going to do it again. So I do that, and you notice that R0 gets that value. And what's now going to happen is it's going to take each of these values and just start dumping them out to the screen until it gets to a 0. Look for it right there. See? That's going to be the exclamation mark, the 0021, same. Then boom, 0. When it gets to this 0, that's the null termination of the string. Boom. Thank you, Zach, who's not even here to be slow clapped or anything. Zach just got here. Zach, you're here in time for the slow clap. I was just walking through the code you dumped on Halloween because it was just kind of pulled a lot of things together and gave us a good excuse to pull up the LC3. Thank you, Zach. You're like a son to me, Zach. You're probably wondering, wow, what kind of relationship do you have with your sons, man? This is really bad. Okay. All right. Everybody cool with that? All right. Okay, there we go. That's it. For now. But the LC3 has to be your friend, okay? That LC3 Simulator has to be your friend. And then you can always search for it, but I'll just drop I'll drop the link again here. And that is also on the syllabus. But and big thanks to, I can't remember the guy's name that did this thing and posted it on GitHub for everybody to use. Massive appreciation for the effort. And it's really quite a good effort. There is one change I want to make to it. Zach, make me do this. Zach, help me do this. Let's do this. There's one thing relative to the assembler that makes me crazy, and it limits our ability to make jump tables. Okay? You good with that, Zach?
Yeah. Yeah, I remember how much that pissed you off last semester.
It did. It still does, too. And I'd like to, well, it just limits your ability to write really good assembly language code. You know, if you can't, if you have to jump through crazy hoops to make a jump table, you know,
Yeah.
not bueno. Okay, here we go. Yeah, problem solving. Okay, here we go. And by the way, we started this at 6, so we're going to go 7:15, which is about all right. What do we got? Yeah, it is, we got about 25 minutes. All right. So here's the thing, problem solving. We've given you a crap ton of tools, okay? Bunch of tools. And again, remember, by the way, as you do this stuff, as you get stuck, whatever, try to noodle it out, try to figure some stuff out, but we are available, TAs are available. Here's the thing. Look, here's the deal. I'm working on my Biden. It's a work in progress. I got to get used to this. Look, here's the deal. Let's face it. So not everybody's good at this, okay? Not everybody is good at the whole problem-solving, engineering thing. Some of that's aptitude. You can always get better at it. I do believe you can improve it. And I think there are some people, I think there are some people that struggle forever, and maybe it's just not a great match. It's going to really be an uphill battle. Other people that just seem to have a natural, kind of a knack. And, but this is a really, really important thing, and it relates to what I call step 0. When you don't know what to do, okay? When you don't know what to do, you can't just throw up your hands. You can't just, okay? So here's what happened. This really surprised me the very first semester that I taught this class here at UVU. This was the fall of 2018, so this was only 5 semesters ago. But when we got to the final project, the larger program, I had multiple students say to me, like really exasperated, really frustrated, really exasperated, and just kind of go, I don't even know where to start. And I'm literally, that was like the expression. I don't know if that was like, I couldn't figure out if this was something that they were like everybody when you came to UVU and got to the CS department, that they issued you a little card where okay, when things get really difficult, remember, you don't even know where to start, and then with a throw up your hands, emoji. I mean, I couldn't figure it out because it was like half a dozen different students said the exact same words to me. Like was that cultural? I don't even know where that was coming from. And I understand the emotion, but I don't understand, or I don't think it's productive to, have that be your position. Like this, my position and my official position is, I don't even know where to start. That whole thing, it's okay. So, and here's the thing is, number one, what I think they meant to say, but did not say correctly, they were imprecise and therefore inaccurate, was they don't know how to finish. They don't know how to do it start to finish. And the problem is, so many of what you have done to this point, right, thank you, Mike. Key to problem solving is being okay with the struggle and breaking it down into smaller problems. You have to be okay with the struggle. That's the starting point. And the key is, when they say, I don't even know, and I'm sorry, I have this exasperated tone, but this is what they sounded like to me. I don't even know where to start, almost like a point of pride. Like, I don't even know where to start. Extreme exasperation. And what I said to them, and this was before I made this part of the lecture, I said, no, that's not true. That's not true. I don't even know where to start. No, you don't know how to finish, but you do know where to start. You know where to start. And it is not going asking somebody on Stack Overflow, okay? Or on one of these piece of crap cheat sites that short circuit your education and compromise your actual learning, because degrees are not, grades are not, all the rest of that. You get into a job, and if you suck, everyone's going to know you suck. I mean, it's not going to help you, you know what I mean? To cheat your way through crap by looking stuff up instead of, there's a part where you labor through it. You grind it a little bit, and you have to be a little bit relentless. That is in engineering ethic. Thank you, Cody, right? This is Rocky, man. Hey, it ain't over till it's over. It doesn't matter how many times you get knocked down. So, no, right? But this is the engineering ethic is, look, figure it out. Now, and this also is something that I didn't really talk about a lot. I did post some readings that you can get to on the orders of ignorance, but which we just don't have time, and I'll talk about it more. Take 3450 from me, take 305G from me, and I'll talk about the orders of ignorance. But what I want to say is, it's being okay, being comfortable, not knowing crap, being okay, not knowing. We're so dialed up with, I don't dare say I don't know something. I don't, it's like, and then people will say stuff and you're like, oh, the one thing, and you're like, oh yeah, and you have no idea what they're talking about. But if you get really comfortable at being like, I don't know what that is, right? Then you're always learning. You're always learning because you're open, because you're not trying to protect your image. You're just trying to actually know, right? And the only way to know, paradoxically, is to admit that you don't know. So when you posture and act like you know stuff when you don't, you close the door on actual learning. And when you're open, you open the door to learning. So paradoxically, if there's a group of people in a room and you show me the person most willing to say, wait, what is that? What is that? I don't know what that is. All right? I will show you the person who is most likely on any given random point to actually know the thing. And the person who is least likely to admit when they don't know something is also the least likely to know a given thing when it comes up. Okay? Because they don't admit when they don't know stuff. And therefore they can never learn. And they're always posturing and living in fear that they're going to be found out. And what are they worried about being found out about? Not knowing a thing. Guess what? Guess what? Chicken butt. That's what. No, guess what? Every day, if you're living in a world of growth, if you're living in a world of learning, every single day you are encountering crap you don't know the answer to. Get used to it. If you are saying I don't know every single day of your life, you're doing it right. Okay? So you got to start by just not being afraid to not know stuff and to throw up your hands real quick and go, I don't even know where to start. It's almost like I'm almost putting they would throw their hands up literally, and it was almost like I don't know where to start, so why don't you keep your distance? Because it's going to feel uncomfortable if I have to tear it open and let you come in with your knowledge and with whatever. I feel awkward. Well, we got to get over that, okay? The engineering ethics says we're going to figure it out, I don't know what it is. I don't know the end. I don't know the answer. I don't know where we're going with all this. I'm going to figure it the hell out. That is what it means to be an engineer. And it doesn't matter if you're a software engineer, hardware engineer, mechanical engineer, civil engineer. You know the difference between civil engineers and mechanical engineers, right? Mechanical engineers build weapons and civil engineers build targets. But no, it doesn't matter what kind of engineer you are, right? You're in this journey and in this quest to figure stuff out, okay? Oh, the lawnmower. Yeah, let me tell you the lawnmower story. So this is a true story. This was the same year. I was 28. I was at HP in California. And I had this little rental house, and the lawnmower belonged kind of with the house. It was a lawnmower, an old lawnmower. And one day I'm out there mowing the lawn, and I pull the little rip cord, right? What do they call that thing? The little ignition rope, the little pull start rope unit, and the rope just snapped off, down in. It's like snap, and then the remainder just like sucked back in, and you could hear it go flip, 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 like down inside. I'm like, crap. And I'm really, really poor, right? At this point, even though I'm an engineer and I had a good offer, but I'm living in the Bay Area. Half my salary went to my rent, and the other half of my salary went to my student loans. Well, mostly my wife's, but you know what I mean. I'm saying it was rough financially. So I didn't like oh, let's go buy another lawnmower. I was like, no, we got to fix it. So I just grabbed my toolbox, and sat down with this lawnmower, and I started tearing the lawnmower apart. Okay, and just kind of systematically. Okay, but what am I doing? I've had some physics. I've had some basic things, and mostly I'm just not afraid to dive into something. And so I start tearing the thing apart, you know, piece at a time. I'm careful, right? Take it apart, put it down the sidewalk in the order that I'm taking it off. And eventually I get down there, I find the rope, figure out how much length I need. I go to the store, I buy the right kind of rope. I come back, go back in, tie it, zingity zingity, run it out the other side, put it all back together. So somewhere in the process, it's torn apart. And my wife comes over and she's like just looking at me with that special look. And she's like, I really think you need to call, you know, whoever, the owner, right, who lived like across the street and up just a little ways, right? I think you really need to call the owner, you know? And I'm like, no, I don't need to call the owner. I got this. And she's like, you need to call the owner. And finally I said, look, hon, I'm an engineer. Just back off. And then she says, you are a software engineer. This is a hardware problem. You are out of your depth, right? And I was like, now, of course, you throw the gauntlet down, right? You want to throw down the gauntlet. Well, we're going to certainly do this thing. No, but I got it. I put it back together. It was working great, you know? Yeah, that's right, Mike. That was not my first mistake. That was a mistake of an N much larger than 1, okay, in that moment. Okay, and I did the same thing with my station wagon because we had the little Bambinos at the time. And my station wagon, the water pump went out on my station wagon, and it was going to cost like $600 or $800. It's $1988. I'm poor. And so what do? I go and I buy a water pump for $150. I'm thinking I'm going to save myself $800 if I can fix this thing. It's the water pump in a Buick Century station wagon. No, I had never done this before. I'd done various things. And so anyway, same thing. I got a Chilton's manual, which has the blow-up view of all the parts of that car. And I started just taking it apart. I literally started to take my engine apart for the station wagon. And I just put it a piece at a time around the garage, okay? It took me about 8 hours on a Saturday. I made like $100 an hour that day in net value of what I would have had to have coughed up to somebody to do this. And I just, you know, literally every bolt, you know, a piece of masking tape, a number, draw pictures of like the serpentine belt, like drawing the pictures, taking these things apart and moving it. And the parts went all the way around my garage and back around the side. I really wish I had a picture because it was a glorious engineering moment for me. And anyway, and I finally got myself down to the water pump, which is down inside the engine. I mean, I'd like torn the whole front of the engine off, and I got down to the water pump, and the only thing I didn't have was a torque wrench. So I just kind of eyeballed that, you know, just like, I sure hope this is right, you know, and put the thing there. And then I went back the other direction and pulled each piece. Point is, I did not know how to finish, but I did know how to start, right? And these are in the days before Google. So, you know, it wasn't, you know, now today, one of the ways you start is you'd go watch a bunch of YouTube videos about how to do the thing, right? See who you like, what they do. That's nothing wrong with that at all. Learn from people. But I'm just saying there's a process by which you figure it out. You don't know, but you ask yourself, what do I know, right? I don't know how to start. Yes, you do. Okay, well, I don't know how to finish. Correct. What do you know? What do you know? Okay, I know that this is going to be a program in LC3. Correct. Well, what else do you know? I know that LC3 has these opcodes. There's like 16 of them because it's 4 bits at the start of these. I know that LC3 has memory, that in this memory are instructions. I know that these are my toolkits, right? I know how to do iteration. I know how to do, you see what I mean? I do know a bunch of stuff. I just don't know how to finish. So you have to be willing to just take a step out into the darkness a little bit and just say, I don't know how to do that thing, but I'm going to take the first step. Now, as a little kid, and maybe I had this knack or whatever, but as a little kid, I used to tear stuff apart. Maybe, I don't know how many of you were like that, you know. Some of you were not. But I used to just like, I didn't usually tear apart stuff that worked. But I usually tore apart things. Like if there was something that was broken, I would ask my mom if I could like just tear into it, you know? Right? So Zach, I don't know exactly how to, I got to play that and get the audio to be produced for this thing here. It's coming up in the slides, right? I'll figure it out. I'll figure it out. But, yeah. And so what I would do is I would tear it apart, trying to understand it, trying to figure it out. And I never like fixed it and got it back working again. But in fact, I think what I'm going to do when I get to this slide, I'm going to pull it up here. Let me see. I have a video I need to show you. And the problem is that I don't have this system yet worked up. I need a Windows machine because of the struggles with Discord for Mac. Seriously. Okay. Okay, hang on a second.
In over 100 years, we've never missed
I'm going to, I just want to cue it up because I want to show this to you. And I'm just going to literally just do this on the screen because it's about the best thing I've got. And it's probably as good as anything right now.
Little Dilbert.
Okay.
He's not like.
Hey everyone, I'm Rick Beato. On today's
No, not
episode-
Rick Beato, man. I love Rick Beato, but
I'm worried about little Dilbert. He's not like other kids.
here we
What do
go.
you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our
Yeah.
clock, and the stereo.
That's perfectly normal. Kids take things apart.
Ooh. The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I'd want to run an EEG on him, but the machine isn't working.
We're doing on the video.
It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical, and utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer. There. Don't blame yourself.
Will it go away over
There. Don't blame yourself. Anyway, that I just wanted to share that. It never does get old. The knack. I'm afraid your son has the knack. Yeah, right. So you don't have to have been that, that kid. But if you did, there's a little bit of a leg up in a sense because you've not been afraid to just try stuff, right? But if you haven't had that, that's right. No, I'll get banned. I'll get banned for jump still. I gotta drop some copyright notice, into that stuff. Anyway, all right. Let me see real quick. It's honest work. Yeah. Yeah. So the point being that the attitude of an engineer, you have to just be like, okay, you know how often the documentation doesn't actually match the system when you're working as a professional engineer? Like all the freaking time. It's all the time. And if you're just like, if you throw up your hands, you have to be like, okay, I don't know the answer. I don't know why. I don't know all the things. What do I know? What can I figure out? How many ways can I approach this? How many ways, there's that part where you dive in. And as you learn and become more acclimated to diving in, it does get easier to dive in. The skills grow, okay? So the other thing too, and this is really important, this last bullet, the real world does not include disambiguated problem statements like college does. I mean, college, it's like if the homework assignment, and I understand this, what I'm about to say, but if the homework assignment is like ambiguous or not clear, and appropriately so, you'll be like, hey, this is not, especially because you're gonna be persnickety when when you grade me on this thing, and it's not really fair when this isn't clear. Fine in the academic setting, but you understand that in professional settings, and some of you have already begun to play in those settings. There's nothing really like syllabi and homework, and the academic world doesn't really prep you. It teaches you stuff, but it doesn't fully prep you to just be an engineer in a world just awash with ambiguity and imprecision and uncertainty. Okay, you have to just figure crap out all the time and forever, right? I've been just figuring crap out. I think for like 40 years, I've been figuring crap out, as an engineer or professionally, and it just never stops. It never stops, right? But as you get that ethic, then you just are the one that somehow can get the DVR to work, or you're just the one who can get the Chromecast to work. And it's not because you're like, oh yeah, I had a college course on Chromecast, let me handle this. It's because of the general ethic and the problem solving skills, the debugging skills, the kind of the engineering ethic you bring to bear. Okay? So, okay. Now I think there's the knack, okay, which I already showed you. Apologize for this little shaky cam, but it does get me the audio out here. I'll eventually figure out the other thing. I haven't figured it out yet. So here's what I want to talk about for just a few minutes, and then we'll break, because I probably need some nutritious Costco dogs. Costco dogs for dinner, if anybody wants to join me. That is the best. It'll kill me fast. But those dogs from Costco, they're good. And that's what's for dinner at my house. So, systematic decomposition. All that really means, Mike said it, I think, earlier, it's just a matter of like, look, break the thing down, right? Oh, I'm sure your steak was fantastic. You break it down. I got this thing I got to do. I don't know how to do it. I don't know how to do it. Do I know anything? What do I know? Let me take the next step. Let me take a first step, right? And it doesn't matter what the quest is, right? I want to put a yard in. I want to build a fence. I want to do a thing I've never done before. You can research it and learn about it, which is great. But even if you don't, you can take that, whatever that quest is. I want to climb Mount Everest. How do I do that? Well, you start to learn. You start to break the problem. That's a bad example, because I would just be dead. I would be dead in base camp within about a day. But you know what I'm trying to say? There are just these things that are, how do you do a thing? I've never done a thing before. Anyway, people that acquire that ethic, either they have it innately like Dilbert, or they acquire it and learn it. They get to be the kinds of people that it doesn't matter if they've ever done that thing before. Okay? It doesn't matter, because they just dive in and they figure it out. Whatever it is. Okay. So we sometimes call this stepwise refinement, but it really just means, here's the whole big problem. I don't know, pick something. I don't know, what would be an example of something that feels daunting, that might just fall to you? I don't know. How do you plant a tree? Maybe you've never planted a tree before. What do you do? I mean, you start by researching and understanding stuff, but you're like, well, I know that there's a phase where I have to acquire a tree, and I know that there's a phase where you have to prep some stuff and actually plant the tree, and then there's this part where you're like, nurture, plant a landmine, nice. nurture the tree out. There's kind of like 3 phases, right? Get the tree, plant the tree, nurture the tree, right? Afterwards. Okay, well, getting the tree. What about getting the tree? Well, you know what I mean? You're like, well, what is that? Well, I don't know. I got to pick what kind of tree. Well, where are the places who even sells trees? What do? You jump on Google Maps, who sells trees? You figure that, you break the problem down a piece at a time, right? Right, Mike. So Mike said, if anytime you're making a web app or something on your own, this is literally all you're doing. That's right. You are literally just learning. It is the number one thing you do, in fact, as a software engineer, is learn. It is your number one thing you're paid to do is learn. And that's weird, but it's really, really true. Because really, after we do everything we can through an undergrad program at like UVU, which is a good program, and you come out and you've had these great experiences, you built your compiler and you've done these things, right? And then you go to do your first job, you understand that you're going to be doing something that no one's ever done before. Everybody. Because if somebody had already done it before, they would just go grab that. But the software needed is expanding exponentially faster than you can even get to it. Okay? How are we doing on time? We're about out of time. But you've got to understand the problem. You've got to disambiguate the problem yourself. You've got to understand and try to articulate the potential solutions, okay? So you can break the problem down into solvable chunks. And once it's really exhilarating when you figure this out. It's exhilarating because you suddenly realize that there's just kind of nothing that you can't do because the process is always pretty much the same at a high level. And what I always do, is, you break the thing down, then you put it all kind of back together. But what I do, I don't know if I've got this now. I'm going to come back. We're going to pause here. I want to just finish my thought and then we'll wrap up. My process for life, actually, really truly for life. You might want to write this down. You might want to write this down, boys and girls. Dr. K's plan for life. My process is actually, it's really, really simple. And I am serious as a heart attack. I'm even more serious than I was about my candidate for president. Okay. My process for life, for business, for everything is step number 1, figure out what the next right thing to do is. Okay. That's the first big step. Figure it out. Okay. Number 2, do that thing. And then rinse and repeat. Just then go to 1. Well, now what's the right thing to do? Figure it out. Do that thing. Okay? Now here's another thing. Let me just throw this out as long as I'm on a roll. But also, Mike, sometimes do it. What is the right thing? Sometimes it's also think about a big picture might be the right thing. Right? So it's not strictly greedy algorithms. Because sometimes it's also like think about retirement, think about big picture, think about longevity, think about short. It is still what's the right thing to do. And it's going to not just be the greedy algorithm stuff, but it can also be kind of searching for a global optimum is sometimes the right next thing to do. You know what I mean? So it's not really narrow. And this has to do with the part where we get afraid to learn stuff, right? Sometimes we get afraid to learn for whatever reason. Okay, here's what I want to say about that. And again, a little bit of kind of like Dr. K life philosophy. You can put this in your pipe and smoke it or do whatever you want to do with it, or dismiss it or disagree with it as well. And then I'd love to hear that and, engage me and love to hear your perspective on it. Sincerely. There are a lot of people my age that have, they don't know how to do Facebook. They don't know how to do Instagram. I'm not saying that's the measure of all truth, but they're terrified to learn. And then they do this, like they're still listening to whatever the music was in the 70s. They're stuck listening to whatever that was. They've been, they haven't listened to a new album, in 40 years. They haven't read a book in 40 years. And that, anyway, everyone's got to live their life. But for me, that's not a recipe that holds a lot of appeal. And I've always tried to be stretching, pushing, because as we've talked about, I want to be harder, faster, stronger. Once I got it out of order again. But you know how I feel about that. So what I've tried to do, just, my entire life, and as I've gotten older, is, pick up another language, pick up another instrument, musical instrument. I started playing bass when I was in my late 30s. And I started playing guitar when I was in my late teens. But I didn't pick up the bass till I was in my late 30s. I didn't pick up the drum kit until my late 50s. It's just like, you know what I mean? I didn't make a serious study of Spanish until I was in my late 50s. I'm just saying, I'm not trying to like humble brag. I'm just saying, you have your thing. What's your thing that you just want to do, right? That you want to learn that you didn't know before? What is it? For me, it's language, and it's musical instruments, and it's certain things, right? That you never stop. You never stop growing and striving. So one of the things I figured out somewhere along the line, I think I began to develop Dr. K's theory of learning in my late 30s, I think, probably, which was the late 90s. But I realized something because I was teaching myself to play the bass. And for those of you that play the bass, there's this thing you do with the bass where you do it's a two finger pick like that, okay? And it might just seem like, yeah, big whoop. It's like, it's really unnatural if you've never done it before. You're in this position and you're trying to do this walk, and it doesn't matter which side you start on, which finger you start on. And that's kind of the standard two-finger pick. And I didn't want to play with a pick because I didn't want to be a poser like, Paul McCartney. Right? So, anyway, I wanted to learn to do it that way. But I remember just being really, really frustrated. I was trying to do it, and I couldn't get it. I was just like, I put my bass down for like 3 weeks or something, a couple weeks. I just didn't pick my bass up. Like School of Rock. And a couple weeks later, I picked my bass back up, and I could do it. I mean, I could do it like fluently. And so you usually think of like, I got to practice. I got to grind it through. I got to keep going until it clicks. And I don't think your brain actually works like that on balance. So Dr. K's philosophy of learning. Are you ready for this? Step number 1, enjoy doing it, even badly. But you just enjoy it. You're like, I don't care if my Spanish sucks. Damn it, I'm going to learn Spanish. I'm going to be fluent, in Spanish. So it doesn't matter if you suck. Everybody sucks when they start everything. That pretty much is true. Some exceptions, but mostly, right? So step number 1, enjoy doing it badly. You just love the feel of the bass in your hand, or you just love doing the Duolingo, or you love whatever your thing is. I just love diving into an engine even though I don't know what I'm doing, or I love whatever that is, right? You just love it. And you don't care if you're bad, which is part of that not caring if you don't know, right? You enjoy doing it badly. That's step number 1. Step number 2, trust your brain. Trust your brain. That's it. That is it. Enjoy doing it badly and trust your brain. Your brain wants to understand it. Your brain wants to figure it out. Okay? Zach, awesome reference. Can you drop an Amazon link, maybe, Zach, for everybody? That would be fantastic. You know how many new book recommendations I've pulled down this semester? Yeah. All right, that's it, man. Enjoy doing it badly and trust your brain. Your brain, the reason I was able to put the bass down and then pick it up, a couple weeks later, playing better than I had without practicing, because there's background threads in your head and they're going. They want to figure this thing out. They want to get the fluency, and they will, in fact, keep cranking. They'll keep pounding while you're not even doing it. While you're sleeping, while you're doing other stuff, it's still trying to solve that puzzle, because your brain loves to make the connections and solve the puzzles. All right. That's why puzzles are fun, because you have to connect the dots. It's why comedy is fun, because in every comedic moment that you find funny, think about this, there is a connection that you have to make. And if the connection is too small, there's no jump, it's not funny, right? If the connection is too big, like spark plug, gap, if the gap is too big, you can't bridge the spark. The humor is too obtuse. You can't get to it, right? So there's got to be enough of a gap that you have to connect the dots or solve a puzzle, right? It's one of the reasons I despise puns, because for me the gap in the spark plug is just too small. You didn't do much. You know what I mean? In my view. Now some of you dig that. Okay, that's all fine. That's your problem. But mostly it's the problem of the people you hang out with. It's mostly their problem, right? Anyway, you know what I'm trying to say? There's a gap. There's a puzzle. Your brain, when people do the comedy thing, and they really set you up, and you solve that puzzle and it connects, it creates such a buzz in the pleasure centers of your head. Your limbic system goes nuts, and you start to convulse and laugh and have this physiological reaction to the joy and the pleasure in your head because you solved a puzzle, and the comedian set you up to do that. That's why we pay these people to entertain us, okay? Trust your brain. Your brain wants to solve the puzzle. So whatever it is, enjoy doing it badly. If you like it, do it. If you do it badly, don't worry about it. Just stay in it, and it'll come. It really will come. Same thing with, bringing this back around, same thing with the LC3 assembler and the machine language and all of this stuff we've been doing. If you just enjoy it, it really will begin to distill out in your head. So that's the learning gospel according to Dr. K. And that is really a wrap. We're over time. And anyway, God bless America. The day after the election with nothing settled anywhere, basically. So anyway, thanks, Zach, for the recommendation on the Barbara Oakley book. I really, really want to take a peek at that. And so, all right, I'm out. I'm not playing any music today. I'm not going any outro. Sorry, everybody.
Do you have one hot second, or are you ready for your hot dogs?
Oh, that's a loaded question. Like, what do I love more? My students?
I know you love your hot dogs
my
more.
students or my Costco dogs? No, they're not. Like, it's not like they're like coming hot out of the microwave. I mean, I have to go prep them. You know what I mean? Create my little sauce and my herbs.
I can another topic.
No. Go. I'm good.
It's just a question on the homework. If
Okay.
That's fine.
Yeah. So, and I can leave the video go if anybody else, if it's about your homework, or is it about generically homework?
Like module 5 homework.
Okay. Well, let me do this. I think I'm really cool, like letting it roll. But I think what I'm going to do is just stop the YouTube stream, and then just hold tight, okay?